Distributed Control System Part 1. Some questions and their answers. Question: when do we use proportional controller? Answer: proportional controller is used during the following conditions: load changes are small, offset error can be tolerated, the process reaction rate is such as to permit a narrow proportional band, since this reduces the amount of the offset. When do we use integral controller? Integral controller is used when the offset must be eliminated, when integral saturation due to sustained deviation is not objectionable. Request: it is hoped that this session is going to be useful to you. Please press like. Please subscribe. Question: when do we use derivative controller? Answer: large transfer or distance velocity lags are present. It is necessary to minimize the amount of deviation caused by the system changes. When do we use proportional plus integral controller? Proportional and integral action is employed when system changes are small. Offset must be eliminated. There is no objection on the duration of recovery. When do we use proportional and derivative controller? PD action is employed when the system changes are small to improve the recovery time, when system lags are high. When do we use proportional, integral and derivative controller? PID controller is used when system changes are small. Offset must be eliminated. System requires fast recovery time. How can we measure differential temperature? Presently, this is best achieved by using a smart temperature transmitter with two sensors. Smart temperature transmitter is transmitting a signal proportional to the temperature difference. Question: in split range control, whether the signal is splitted through IP converter or the control system itself? Answer: this can be typically achieved by two ways: by connecting output of one IP converter to two positioners adjusted suitably for split range operation of control valves, taking two outputs from DCS. Split range to be defined in DCS. Both IP converters and positioners to be calibrated with inputs as 4 to 20 mA DC and 3 to 15 psi respectively. How is cold junction compensation in thermocouple carried? This is typically performed in modern programmable instruments by means of measuring actual reference junction temperature using a temperature sensor or mounted close to the reference junction and compensating for the same using appropriate lookup table stored within the instrument's memory. Question: in which applications do we use 4-wire RTD? Answer: 3-wire system is a better alternative. Primary objective of 3-wire and 4-wire arrangements is to eliminate effects of lead resistance on temperature measurement. What is the sensor used in Coriolis mass flow meter to measure density? Answer: density is measured here by measuring the resonant frequency of a vibrating U-tube. What if thermocouple wire is opened in the field? What signal goes to DCS? Answer: in most modern instruments, the signal may be programmed to go to either maximum or minimum depending upon end user's requirement. What if the power supply connection to a 2-wire transmitter get interchanged? What signal will go to DCS? Answer: usually there is a blocking diode to protect the transmitter against supply reversal, and almost zero current signal should be transmitted. Question: how can we say that the given RTD or thermocouple is correct? Answer: we can only measure sensor output resistance millivolts accurately and look up corresponding temperature in reference tables. The accuracy depends upon quality condition of the sensor. Degraded sensors may not give accurate readings and must be replaced. To test a sensor, the sensor response may be tested using a high quality temperature calibrator and compared with reference tables. Question: in some cases, we have to select the cam position in a control valve for different application. How do we select that? Answer: refer to instruction manual for the positioner/control valve. The cams are often marked with limited amount of information, which may help an experienced person only. Question: what is the difference between a hard patch card and a field terminal assembly? Answer: a field terminal assembly is a DCS component where field signals are terminated. In a DCS using analog transmitter signals, but smart remotely configured transmitters, field signals from barriers are first brought to a hard patch panel. From here, the analog signals are wired to the DCS field termination assembly or input-output card. The digital signals are wired to the hard multiplexes, which extract the digital information and provide two-way communication path between smart instruments and a computer running suitable software. What is the difference between a protocol and a field bus? A protocol defines a standard method for communications. A field bus is a multi-dropping arrangement where multiple instruments communicate with the spatial interface hardware using the sum pair of same pair of wires and in most of the cases draw power from the same pair of wires. Request. It is hoped that this session was useful to you. Please press like. Please subscribe.